Coming to equivalent circuit diagram, primary side and secondary side. This is supply voltage V1, primary side current I1, which is vector sum of no load current I0 and secondary reference current I2 dash. This is primary side impedance R and X. This is resistance of primary winding, inductance of primary winding. This is no load current I0. This is working component IW, magnetizing component IM, R0 and X0. Primary back EMF E1 on secondary side, secondary back EMF E2, secondary impedance R2 and X2, secondary current I2 is also considered as load current, V2, load voltage or secondary terminal voltage. This is load impedance ZL. This is the first representation. The no load network is represented after the impedance. So in order to avoid voltage drop calculations, this no load network can be represented before the impedance network. So this is the no load network and this is the impedance. Supply voltage V1, primary current I1, no load current I0, secondary reference current I2 dash. I2 dash can be KI2 and this is primary back EMF E1. Till this is primary part. Now the secondary part is also transferred to primary side. Here E2 by K. K is the transformation ratio from this formula. K equals to V2 by V1, E2 by E1, N2 by N1, I1 by I2. This is the transformation ratio K. I2 is transferring on the primary side. It becomes KI2. Impedance R2 by K square, X2 by K square. And voltage by K. Here the voltage terms are divided by K. Current terms are multiplied with K. Impedance terms are divided by K square. When secondary part parameters are getting transferred to primary side, then voltage terms will divide by K, current terms will multiply with K, impedance terms will divide by K square. If there are any admittance terms, those must be multiplied with K square. So these are the important notes. This is step 2. Now coming to step 3. Here the impedance terms are simplified and the voltage terms are neglected. Back EMF voltage terms are neglected. So the finally net impedance is R1 plus R2 by K square, X1 plus X2 by K square. This is when secondary terms are transferred to primary side. Similar type of calculations can be done so that primary parameters can also be transferred to secondary side. In that case, the net impedance will be R2 plus R1 into K square, X2 plus X1 into K square. In this case, when the primary parameters are transferring to secondary side, then current terms will be divided by K, voltage terms multiply with K, impedance terms multiply with K square, admittance terms divided by K square. Fourth step, the net impedance is represented R equivalent and X equivalent. This no load term, this is very small compared to full scale rating of the transformer. So no load network can be omitted. So in the fifth step, the no load network is omitted. So finally, the transformer is equivalent to net resistance and net inductance. On very large scale, the resistance of transformer windings is very low. So the resistance can also be omitted. Finally, the net equivalent circuit of transformer is only inductance. So on large scale, the transformer is equivalent to a inductive coil. This is a total equivalent circuit of transformer. This is final sixth step. Whereas the primary voltage V1 equals to voltage drop plus secondary terminal voltage. These are the vector diagrams with reference to primary and with reference to secondary. These are the net equivalent circuits. So this is the primary voltage V1, primary current, primary resistance, secondary resistance, primary inductance, secondary inductance, net resistance, net inductance, and this is the terminal voltage across the load. This is the load current. So here the supply voltage V1 is total voltage. So V1 is terminal voltage plus impedance. So this is derived equation from this vector diagram, or the vector diagram can be prepared with the help of this equation. In this case, the plus means lag, minus means lead. If the phi is 0, that is resistive load. This phase angle depends upon type of load. Similarly, this is the equivalent circuit when the primary is transferred to secondary. Terminal voltage V2, load current I2. These are the secondary side resistance and inductance, primary side resistance and inductance, net resistance, net inductance, primary voltage transferred to secondary side. And this is the net vector diagram. Here V1 dash equals to V2 plus and impedance. This is derived equation. Plus means lag, minus means lead. If phi equals to 0, that is for resistive loads. So out of these equivalent circuits, only these points have to be remembered when we are transferring parameters from primary to secondary. When we are transferring parameters from secondary to primary, how to calculate current and voltage and impedance and admittance, that we have to remember. This is total representation of transformer. This is transformer N1 and 2, number of turns, primary voltage, primary current, primary side impedance, secondary side impedance, secondary current and secondary voltage. The secondary is connected to load. This transformer transfers power from primary circuit to secondary circuit. This is the equivalent circuit calculation. The primary parameters can be represented on secondary side and secondary parameters can also be represented on primary side. But total power consumption or power calculations remains same in both the cases. This is just to simplify the network. These are the very important rules. These must be remembered.